Hi, welcome to the ambiguous case for solving oblique triangles law of sines. So what I want to do is show one sample of a no solution, a one solution, and a two solution, and the thought process that goes through it. So this example here has angle C, and side B. One thing to keep in mind is if you're ever given two angles, you will never have an ambiguous case because if you have two angles, you really know three angles, so there can only be one solution. So the only time you have to think about it could be an ambiguous case is if you're only given one angle. So we're going to go ahead and set up law of sines. I'm going to put the sides on the top. So A over sine of angle A, B over sine of angle B, side C over sine of angle C. I'm going to go ahead and plug in my numbers so I don't know anything about A. So it's going to stay completely with its variables. B, I know simply the side, but I don't know the angle. And I know everything there is to know about C. So I'm going to put the side on top and the angle on the bottom. And I did not grab my calculator before I started this video, so I'm going to grab it real quick. Okay, so for us to solve, we're going to go ahead and do the cross multiplication. Switch colors real quick. So, why did I not put in angle C? This should be 60 degrees instead of C. So we're going to multiply 181 times sine of 60, and we're going to divide by 151. So 180 times the sine of 60 divided by 151. I end up with sine of B is approximately 1.038 and so on. Now you might already see a concern, but let's go ahead and plug it in as if we didn't notice anything. So since I'm looking for the angle, I have to find the inverse. So I'm going to use the -1. So I'm going to do inverse sine of that 1.038 number. And when I plug that into my calculator, I end up with it kicking out undefined. Mine says undef, which is undefined. That just means that there is no solution. So this is an impossible triangle. If I were to actually draw it out to scale, one of the sides would be too short and it wouldn't actually complete the triangle. Now, what I could tell is if I was looking at the number when I did the cross multiplication, right here, this number, 1.038, is over 1. You will never have a ratio where sine or cosine is greater than 1. If you do, then it will always be undefined. Now, you don't have to pay attention to that if you don't want to. You can just always plug it in and your calculator will tell you that it's a no solution or undefined. Okay, so that's what happens when that situation occurs. So let's move on to the next situation. So I have a second triangle drawn. I have angle A and I have side B. So I'm going to go ahead and set up my law of sines. 42.3 over sine of 38 degrees. I have 32.5 over sine of angle B. And I have C over sine of C. So as I look at this, it looks like I can solve for angle B first. So I'm going to do my cross multiplication with 32.5 sine of 38 divided by 42. So I'm going to go ahead and plug in 32.5 times sine of 38 divided by 42.3. Get there. 42.3 sine of 38, 32.5. No, I just multiplied. I'm like, there is no way that is correct. Sorry. My calculator gave me a huge number, which I knew could not be correct. Which we all make mistakes. Okay, so sine of b, it gives me 0.4730, blah, blah, blah. Okay, the number I originally got was 846, so I knew that I did something wrong. Okay, this is under 1, so it probably has a solution. So I'm going to go ahead and do inverse sine of that number. And it tells me that angle B is approximately 28.23 and so on. Now when I look over at my original problem, I can see that my angle is to the nearest tenth, so I'm going to keep it that way. I will answer my angle to the nearest tenth. So angle B is 28.2. Now that I have angle B, I can go ahead and find angle C. 28.2 plus, actually, I'm going to write that differently. I'm going to do 180 minus the 38 and the 28.2. So I have an angle C of 113.8 degrees. Now I still need to find side C, so I'm going to go ahead and plug in 113.8 degrees for angle C. And then I'm just going to do my cross multiplication again. I'll go ahead and rewrite which ones I'm using. So I'm going to use 42.3 over sine of 38 equals C over sine of 113.8. I'll go ahead and do 42.3 times sine of 113 divide by sine of 38. So our sides are to 3 significant digits. So side C would be approximately 62.9. And that is because my unrounded number was 62.86. Okay, so far I've come up with one solution. I have this triangle solved. Now the question becomes, is there a possible second solution? Now the second solution is always going to occur at the first angle that you found. So if I go back to my work where I started, the first angle I was working on was this angle B. So angle B is the first one that I found. This is going to be the supplement of where the second triangle could be. So for a second triangle, I'm going to do the supplement of what I found. So I'm going to do 180 minus 28.2. 180 minus 28.2 is 151.8. Now we're going to see if I can take what I just found for angle B what I was given for angle A to come up with a new angle C. So I would do the same thing I did for the old angle C. Let's see if I can move down just a tiny bit to give us a little bit more room. So for a new angle C, it would be 180 minus 38 plus the one, I just lost it. Where did it go? 151.8. So if I add those two, I get 189. So these are 189.8. And if I do 180 minus 189.8, I end up with a negative number, negative 9.8, which is not possible. So that shows that I have to have a single solution because this one right here, if I try and find a second solution, I end up with an impossible situation. Just like on the first one, I ended up with a no solution because I can't have a sign ratio that is greater than 1. So this was the example of the single solution. So let's go ahead down here. So you can probably figure out this is going to be our one that does work for a 2 solution because I did a no solution and then I did a 1 solution. Now we're going to do a 2 solution. So, and what I was trying to show you, I tried to have an angle A, an angle B, and an angle C given. It doesn't matter what the given angle is. These can all happen. The key is that you only have one given angle, not 2. Okay, so let's just set it up and start solving as we were earlier. So I have A over sine of A, B over sine of B, C over sine of C. So I don't know anything about A. That's going to stay alone. Looks like I know everything about B. I have 451 over sine of 8 degrees. And on C, I know the side length, but not the angle. So the first thing we're going to find is angle C. Right here. So I'm going to multiply 855 times sine of 8 and then divide by 451. 855 times sine of 8 degrees divided by 451. I end up with 0.263 and so on. So I'm going to inverse sine that since I'm looking for the angle. It kicks out that angle C, and again I can see this is to the tens place, so it would end up being 15.3 degrees because I got 15.298 and so on when I plugged it in. Okay, so I know angle C. Angle C is 15.3 degrees. Since I know angle C, I can find angle A. A is 180 minus 8 minus 15.3. That's just another way of writing it compared to what I wrote up above, but it works the same. So angle A is 156.7. Now that I know angle A, I can go ahead and find side A. So side A over sine of 156.7 is going to equal, and I do always like to use the one that's given, where everything is given. That helps me deal with rounding. I'm not as far off every time I do the problem. going to go ahead and multiply 451 times sine of 156.7, divide by sine of 8. So I'm just double checking to make sure I didn't do anything silly like I did up above. So I ended up with 1281.79. And it looks like if I look up above, I have 3 significant digits. So 1, 2, 3. So side A becomes 1280 meters. And I'm going to write that in blue just because I wrote the other ones in blue to keep them consistent. So A is 1280. So I have all the blue numbers, which would be my first solution. So the question is, do I have a second solution? So I have to look back to what was the first angle that I found. And so if I look through the work here, looks like the first angle I found was this C. So C was the first angle I found. So if I have a second angle, it's going to occur at C, a second triangle. That's where the rotation will start. So I'm going to restart the triangle at C. So what might help is if you redraw it. So I am going to do that just to see if that'll help. I'm going to do the original in green. Pretty sure that's what I did originally. Yep, the original was in green. So I'll start with the original in green just so you can see what was given. That the given does not change no matter if you're in the first triangle or the second. Side C was 855. Angle B was 8 degrees. And side B was 451. Now the first time we did the triangle, we found angle C to be 15.3. But then we know that if it's going to occur a second time, the 15.3, it's going to be the supplement to that. So I'm going to go back down. This new C, if there is a second triangle, will be 180 minus 15.3, which gives me a new C of 164.7. Now I still know angle B, so angle A will be 180 minus the given 8 minus the new C that we found. So I have 7.3. Now, this actually is working, and the reason I know it's working is because the 3 angles do add up to 180 degrees, and they don't go over 180 degrees. It won't work when you go to do your third angle if your first 2 add up to over 180 degrees, like it did in this last, in the last example. Now that I have the angles, I can go ahead and find the missing side, just like I did in the first solution. So I need to find side A. So I'm going to go ahead and use my law of sines. I have A over sine, this time of 7.3, because I'm in the second triangle. My given was 451 over sine of 8 degrees. My cross multiplication and divide. 451 times sine of 7.3 divided by sine of 8. So my third side, A, I'll go ahead and write what I got. I got 411.7615. And so to 3 significant digits, it would be 412. So if I just kind of put all this together, what I just found out was I was looking for a new A, a new C, and a new little a. So I have angle A, side A, and side C. No, angle C. Let me fix that. Okay, so these are the things I'm finding in the two triangles. In the first solution, we got angle A was 156.7. Angle C was 15.3. And side A was approximately 1280. Then in the second solution, we had a side A of 7.3 degrees, a side C of 164.7, and our side A was 412. The big thing here is that because angle C was the first angle we found, if you look at these are supplementary, which we talked about in the geometry chapter. They add up to 180, and that will always happen in the first angle that you found. Okay, I hope this helps a little bit. If it doesn't, then maybe we should talk personally, and that will work out better. Okay, have a good one.